Okay, so we're going to look at some complex analysis and the algebra concerned of some complex analysis. So here we have a term minus 1 to the power of minus I. So as we can see, we've got the imaginary unit here in the indice. So how are we going to go about dealing with this and evaluating what it could be worth? So one place to start with would be to take the log of this term. So if we take the log of that, we have minus 1 by the properties of log, and then we take the log of minus 1. Now minus 1 is a negative number, so we'll need to put absolute value in there. So log, and of course we want base e, and then of minus 1. So brackets, absolute value, minus 1. And that's where we are so far. But what we've done here so far is we've changed the value of what this is. So we need to take the inverse function of log, i.e. the natural log, which is the exponential function. So now if we go the exponential, do curly bracket here, minus I times log base e of absolute value minus 1, and then put that in there like that, and then close the brackets. So now we haven't changed the value of this first term. So these two here are still equal. Okay, so now what we can do is exponential and minus I, we'll just leave that there for now. But log base e of the absolute value of minus 1, now we can do something with that. So if you check the link in the description below, I've gone into this function in a little bit more detail, but just as a quick refresher, I'll just write that down on here. Log based e of absolute value minus 1. So let's just keep the absolute value there. Okay, so what we do with that is, and don't forget we want to take the principal version of this. So now we have to write capital L log base e. So that's the principal version. With this one there is an infinite many solutions. With the principal version there's only one. So log base e, and now we just go minus 1 in the absolute value, and now we break this apart. So now we go back to using this. So this now becomes log based e of minus 1 plus I times the principal argument. So again, capital letters, so there's only one solution, and then of minus 1. And we don't need the absolute value brackets here, we can just put normal brackets. So just drawing this up on the diagram, let's draw that up, we can draw it here. So minus 1 will appear here somewhere on the graph. That's our reals, that's our imaginaries. So when we're dealing with these two terms, we need to know the modulus. So as that is out at minus 1, we know the modulus is 1. And we need the argument, which is the angle from the positive real axis here. So this angle theta is going to be pi. Just as a quick note, we can't go this way really, because this would be minus pi. Now theta here, theta must be in a set where theta is in between minus pi but greater than and up to and including pi. So the minus pi wouldn't work for us in this situation, we want pi. Okay, so now we know these terms here, log base e of minus 1. So now we've got log base e of 1. So now we've got a positive number, we don't need the absolute value, plus I times the argument of minus 1. Well, the argument of that is just pi. So that takes care of that. Okay, so now log base e minus 1, we can just plug those values in here. So now back to here, exponential minus I, and now we can plug in the values here. Well, the natural log of 1, we know that this is just 0. So basically we can now write 0 plus I pi. Okay, and now what we're going to do now is distribute the minus I with these two terms. And let's write that here. exponential minus I times 0, well that's just 0, I just put it in, minus I times I pi. So we just have to be a little bit careful here. Minus I times I, well we know that I squared is minus 1, so minus I times positive I will be plus 1. So times, so that would just be plus pi. Okay, so now we have here exponential of 0, that's just cancelled out, but plus pi, so now our answer is e to the pi. And that is our answer to this question. Okay.